to the Chem 100 lab for fall 2020. We won't actually be in this lab, but I just wanted to give you a tour of the lab to show you some of the things that you'll be seeing, some of the things that we'll be working with. This over here is me. I designed the labs here, so if you hate them, then you can blame me for that. But hopefully you won't. Hopefully you'll have fun. So a couple of things to touch on first. The first thing we want to talk about is safety. So this is a fume hood, aka a hood. Fume hood is used whenever we're working with volatile liquids. This would be anything that easily evaporates to become a gas, because we don't want to inhale the gas that it becomes. Oftentimes we're doing a dangerous chemical reaction. We'll do it in the hood just to make sure that if anything goes wrong, if the reaction goes out of control, that we're safe from the reaction. So how does this thing work? The doors here slide to close, and the blowers, which are up here, suck all of the air out of the area that you're working in here. So when the doors aren't fully closed, the hood is not going to work as well. But when they're fully closed, there should be no vapors escaping from that hood. So other things that keep us safe in the lab: we have the eye wash station. You guys saw this in the safety video. Safety shower, which I've never had to use, thankfully. Fire extinguisher, also never had to use, thankfully. And goggles. This is one that we'll always be using when we're in the lab. So here's a couple more things to think about. Our chemical containers. We have different types of chemicals are going to come in different containers. Anytime we have a solid, it's usually going to be kept in a sealable jar. The name of the chemical and any hazards associated with the chemical will always be on the jar. Liquids are usually kept in bottles. For ease of use, some liquids might be put in containers that have droppers, like these. These tops are most convenient when we're only dealing with a small amount of liquid that we want to administer drop-wise. All liquid containers, just like solid containers, will always have the label containing the chemical name, the concentration, which we'll talk more about in detail later in the semester, and any hazards associated with the chemical being used. When we have large volumes that we're using, we'll often use what are called stock containers. These are stock containers. All of our chemical waste is always going to go down in the hood, right? So there's different containers for different types of waste. But the vast majority of things that we work with in a chemical lab are going to require special disposal methods. The reasons for this, because they could be corrosive, they might be very environmentally dangerous, they might be toxic to environmental life, they could be flammable, and they could be highly reactive. So you always want to check and make sure that you know how to dispose of a chemical before you're working with it in the lab. So here's some lab equipment that we're going to be using. So first of all, we have lots of different types of instruments in the lab, and we want to talk about what these instruments measure. We have instruments that measure mass, many instruments that measure volume, some that measure temperature, and others that measure length. We won't be looking at any rulers today, but we will eventually. Other instruments are used in the lab to aid the experimental procedure, but are not necessarily measuring anything. So let's look at some of these tools. So first up, we have the analytical balance. We will be using this all semester long. The analytical balance has a couple of key features here. So this is the balance housing, and this makes sure if all of the doors are closed here, it prevents any airflow from making the measurement fluctuate. Now that may seem extreme, but when you have so many decimal places here, so much precision in an instrument, Even the flow of air can affect those measurements, right? So just to make sure that the measurements are accurate, then we close all of the doors here. The balance pan is where we're going to set anything that we're trying to measure here. This little area here is called the display. We always have the units here, and then we have the before the decimal numbers, and then after the decimal we have 4 digits here. This little button here is called the 0 or the tare. It makes the balance value exactly 0, right? So we push tare, and then it becomes calibrated to be exactly 0. So our metric units that we use when we're doing measurements in a chemistry lab, these are the ones that we're going to use completely. No non-metric units, thankfully. So our metric unit for mass is going to be grams, which is abbreviated with a little g. Some non-metric units for mass: ounces, slugs. You've probably never heard of those before. A lot of people think that pounds are a measurement of mass, but they're actually a measurement of force, and we'll talk about that later on. Okay, so measuring volume. We have so many different instruments that measure volume. So let's just talk about a couple of these here. We have a beaker, an Erlenmeyer flask, graduated cylinder, and a volumetric flask. So all of these instruments are going to be giving us volumes in milliliters, which is abbreviated with the M-L. The metric unit, the base unit that we're working with here is liters, but usually in a chemistry lab, a student lab, we're not working with large volumes of anything. So glassware is more often measuring things in milliliters than in liters. Okay, so why do we have all of these different types of volume glassware? So a beaker is going to be one of your least precise instruments. It's really more of a guesstimate tool than it is a really precise tool. Erlenmeyer flask is similar in precision to your beaker. The main reason for using an Erlenmeyer over a beaker would be that you have a smaller opening here, whereas the beaker is going to have more surface area available, have more ventilation. The Erlenmeyer ensures that you get more condensation if you were heating, for example. It also reduces splashing if you're doing a reaction where that's a concern. So when we're actually looking to measure things and not just hold things, we're usually going to be using more accurate glassware. So a graduated cylinder has these little tick marks or increments. That allows us to measure much more precisely what we want. Now, just looking at these here, you can see there's a little TD here. That means to deliver. So that's saying whatever we put in here, when we pour it out, there may be a little bit left over, but that's okay because this is calibrated for that exact type of measurement. Then we have this plus or minus value. This is telling us that we can read this instrument to 0.5 milliliters, right? Plus or minus 0.5 milliliters. So that's the precision associated with this glassware. We'll talk more about that later. Then we have the volumetric flask. So volumetric glassware in general is always going to have a line around the neck, and that's going to indicate for you that this glassware can only ever measure one volume, right? So where the graduated cylinder has increments and you can measure any volume you want, a volumetric glassware, a volumetric flask, can only measure one thing, but it measures it very well. So you see this one has 50 milliliters, and our plus or minus precision here is 0.05, right? So that's really good precision for the measurement that we're looking to make here. But this little line indicates that there's only one volume that we can use with this glassware. Okay, measuring temperature. So when we're in the lab, we're always using thermometers to check temperature. You guys are probably familiar with a thermometer. This particular one is an alcohol thermometer. And this is much, much safer than what used to be used, which is a mercury thermometer. I'm guessing most of you have never encountered a mercury thermometer in your life because they've all but gone away because they're so toxic and hazardous to work with if they break. And so we have an alcohol thermometer, has a range of measurement between negative 20 degrees here at the low end, and not shown here at the high end is about 140 degrees Celsius, right? Notice we're not using a thermometer that's measuring in Fahrenheit. We're using a thermometer that measures in degrees Celsius. Celsius temperature scale is based on the freezing and boiling point of water. So 0 degrees Celsius is the freezing point of water, and 100 degrees Celsius is the boiling point of water. So some other things we'll be using in the lab, we might not be using this semester, but you might see them, so we'll just talk about them. The crucible is something that we can use to heat up a specimen to very, very high temperatures. It's made out of porcelain, which is very fragile, which is annoying to work with, but it can handle very, very high heats without breaking. We have an evaporation dish, which is pretty much exactly what it sounds like. If we wanted to put a liquid in here and evaporate the liquid and just have the residue left over, we could use this. It's also porcelain, so it can handle very, very high temperatures. Glass stirring rod, oftentimes we want to stir a reaction. We definitely don't want to use our hands, so we have a glass stirring rod. This guy is called a combustion tube. So if we want to do a reaction, a small scale reaction, we want a container that's relatively small that we can contain that reaction in the bottom here. This is actually a relatively tall instrument, and its walls are pretty thick here, right? So combustion tube implies that we're going to be making things explode, and that's oftentimes what these are used for. Got a wash bottle. We're using a lot of the times to rinse down the sides of containers or to add a little bit of water to something if we need to. We have a centrifuge tube. We won't be using the centrifuge in this class, but you may see one down the line. The centrifuge tube is shorter than the combustion tube and has a smaller diameter, but it has similar thick walls and does not have a lip on the top edge here. We have a watch glass. A watch glass is often used on top of a beaker or an evaporating dish to slow the evaporation process, right? Oops. And then we have a Bunsen burner. This is used to have fire in the lab to heat things. If we sometimes use a Bunsen burner, but oftentimes we'll use a hot plate if we want a more controlled heat source. And then last but not least, we have our test tubes, right? Test tubes look really similar to a combustion tube, but they have a little lip here, and they're much more thin-walled, and they're much cheaper if you accidentally break them. Okay, so let's talk about the Bunsen burner a little bit more. So when we use the Bunsen burner, we have this tubing, which is going to go to the gas line here. Right? So when we set up our Bunsen burner, we attach the hose to the gas valve, and this is the gas valve here, a little close up. Once we've got that attached, we can turn the gas valve ever so slightly and use a match to light the Bunsen burner here. Once lit, the flame will usually be loose with a pale blue color. Sometimes we get some little orange flares, kind of like this. This is a cooler flame. The reason for that is because we've limited the airflow here at the bottom. So we have regulated the amount of airflow that's coming into our combustion source here. To increase the temperature and focus the flame, we can open up the airflow regulator here. When we do this, what we see is this blue cone that's a much more intense blue than our original flame, right? This is the hottest part of the flame, right? So again, this is going to be a more controlled flame and a hotter flame, right? Okay, so summary of our lab without being in the lab. So I'm guessing that there's some of you at least that are thinking, man, this is such a waste of time. I'm learning about all this stuff in a lab that I'm never actually going to handle, and I'm never going to deal with these chemicals. And I get that. I understand that working with things hands-on in the lab is definitely a really cool experience. I obviously am biased and think it's really awesome. And it sucks that we don't get to do that. But there are some really cool features about our virtual lab that I hope will really help you guys out and that wouldn't be available in a traditional lab setting. So all of our chemical reactions you'll be able to watch and rewatch as many times as you want, so observations will be a lot easier to make. We get to do some more dangerous and exciting chemical reactions that we wouldn't normally work with in a learning lab. You're going to see a lot of tutorials on how to navigate topics from lecture, problem solving, how to do some of the calculations that we go through here. Everything in our course is organized with your learning and different learning styles in mind. So it's really focused on helping you guys and supporting the lecture. You'll have flexibility in terms of when you work on the labs. Depending on who your lab instructor is, you'll have a week or so to work on the experiments. You can start them one day and then finish them the next day. You don't have to finish them all in one go. So depending on what your work schedule is, I think this flexibility can be really, really helpful. It also allows you to pace yourself a little bit better. So if you're a little behind in lecture, maybe you're not ready for the topics that we're talking about in the lab, this gives you a little bit more time to work through that stuff. So the main thing that I want you guys to do above all is have fun, right? Ask questions of your instructors. We all love science and we want to help you. It's a little weird not being face-to-face, but you still do have a classroom full of peers that you can work with remotely, right? I highly encourage you to reach out to other people in your lab and work with them on the labs because it really, really helps having another perspective when you're working on these labs. You can do that via Zoom, you can text, FaceTime, whatever works for you guys, but definitely try and build those relationships in the lab. Good luck.